Hey 8th graders, for the first part of class today we're going to be working on pHet states of matter, so we're really going to review our different appearances and characteristics of our different states of matter, solid, liquid, and gas. And then we're going to talk about phase change, but the main thing about phase change that you're going to learn about today is that there's more than one way to cause a phase change. So up until this point we've learned by heating or removing heat, or in this case adding energy and taking energy out of a system, you guys can cause a phase change to happen. But we're going to look at other ways that we can do that as well, and that's going to lead us into talking about dry ice and how dry ice is made for our next lesson, which is our dry ice lab. Okay, so learning targets, I can model states of matter and demonstrate phase change. All right, moving on, you guys will need this link on the second slide, so right click that and open it. Okay, it will take you to a page that looks like this, and I'm going to kind of bounce through some of these different procedures that you guys do within this little simulation, but I'm not going to go into a ton of detail or show you guys a ton. I'll just kind of show you guys what you're changing on each little scenario. Okay, and then from there you guys will click on states. Okay, all right, moving on. Part one is again reviewing phases of matter, so we can kind of look at some of those different properties of a solid, liquid, and a gas. So we're going to start off with solid neon. So you guys all know neon in its natural state or at room temperature is a gas. But in this case, we're going to freeze this neon into a solid and look at what it looks like. So what I want you guys to do is make sure solid is clicked over here, make sure neon is clicked over here, and then finally you need to change your temperature into degrees Celsius, just because you guys are a little bit more familiar with it, knowing, all right, water freezes at 0 degrees Celsius. So in order to make solid neon, you're 259 degrees below that. Okay, so you're below water's freezing point by quite a bit. Okay, so then you guys can go ahead and just answer these questions, describing the appearance, describe how the atoms are arranged in the solid block of neon, describe the movement of the atoms. We've talked about freedom of movement before, so what are they doing in that solid block of neon? And then what is the freezing point of neon based in the simulation? So that's actually the temperature you take it to if you guys were in a solid state. So if I clicked on liquid, you guys would notice that temperature is going to be a little bit different. So between 246 degrees Celsius, we have a liquid, but if we cool it down any more than that, it starts to turn into a solid. Okay, so you guys can kind of get your freezing points based on that change between a solid and a liquid, and a gas. Okay, so you guys can kind of see, all right, at 217, negative 217, it's a gas, but if I cool it down just a little bit, okay, we're at negative 224. It's going to start turning into a liquid. Okay, so you guys can base off of those numbers as you change between phases. Okay, and then on the next slide for each of these ones, you guys will need to snip a picture. I've already done neon for you guys, so you guys can see here solid neon. You guys will need to do liquid and gaseous neon as well. Okay, now switch your state of matter to a liquid. Describe how the atoms are arranged. So same thing you guys just did. Here's your liquid. Describe how they're arranged. Snip a picture of it, and then move on to gas. Now switch it to a gas. There we go. Describe how it's arranged, talk about boiling point, things like that. Snip a picture. And then moving on, we're gonna compare what we saw as solid neon to solid water. So you guys again can reset. We're gonna go to degrees Celsius. We're gonna choose solid, but in this case, we're looking at solid neon versus solid water. So you guys need to compare how those two are arranged, and if you need to, you guys can kind of flip back and forth. Okay, so compare solid water, which is of course ice, to solid neon. Okay, how does the solid water compare to the solid neon, and why do you think that might be? Okay, so what's different about it mainly? Okay, now change the state of matter from solid to gas. So now let's look at our water in the gaseous form. Mess with the heat and cool option. Cool down your vessel for about 10 to 20 seconds. So you guys will grab this little temperature thing right here, you'll drag it down, and you'll hold that there for about 10 to 12 seconds and see what happens. Okay, and then once you've done that and answered the questions, and you guys are at some heat, you guys are gonna heat it up. Again, you'll click and drag up and heat it for about 5 seconds. See what happens, and then answer the questions. And then heat it up for another 10 seconds after that. Okay, and answer the questions. So really quite simple. All right, now we're moving on to part two, which is phase change. So I'm going to go ahead and reset my sim again. On the right, choose oxygen. In the vessel, you will see a piece of matter in the solid state, so you'll want that in solid. So we're going to go solid, oxygen, and we're also going to change our degrees to Celsius. Observe the pressure meter on the lid. So this one we're really going to start looking at some different ways we can induce a phase change other than changing the temperature. So observe the pressure meter on the lid. When the molecules put pressure on the lid, the pressure changes. Begin by heating up the vessel for about 15 seconds. So we're going to need to switch into phase change here. Okay, and now we can see this little pressure gauge. Okay, again, we are in oxygen, and you can see your solid oxygen. Okay, all right, so again, here's our pressure meter, and we can go ahead and start heating this up and see what happens to our pressure as we heat it up. So we haven't seen anything yet with it, but as our molecules start moving around the container, they're going to start colliding with the lid. And now you guys will notice that our pressure is changing. Okay, so answer these questions here. What two phase changes did you observe in this process? So circle the two you saw. And what happened to the pressure of the vessel as the temperature increased? And what do you think happened that caused the pressure to change like it did? So again, we kind of talked about that just a second ago. What started hitting the top of the lid and the sides of the container to change the pressure. All right, now cool the vessel. So you're going to do the exact same thing, but you're going to cool it down for about 20 seconds almost. And what two phase changes did you observe? So circle your two. What happens to the pressure of the vessel as the temperature decreased? What do you think caused this pressure to change like it did? And then use what you observed here to describe why a balloon filled with helium or any air shrivels up when you take it outside on a cold day. So I think we've all been there before where we've had a balloon in our hand and we walk outside and that balloon totally shrivels up. But then when you come back inside, that balloon goes back to its normal size. It's kind of crazy to think about. Okay, now heat your vessel back up until the oxygen is a gas. For this part, you will be changing the pressure of the vessel rather than the temperature and observing what happens. So there's two ways you guys can increase the pressure. The first one is the air pump on the left. So you guys can click on this and hold it and then move your mouse up and down. And you guys will notice that where that pump is hooked into the vessel, you guys will see more oxygen molecules going in. And then sure enough, you guys can watch the pressure on this container increase as well. Okay, you guys can also kind of see this little bar to see how much oxygen is left to pump in. Okay, so that's one way to do it. And then what directly happens each time you pump the air pump? Look at the point where the air hose connects to the vessel and what happens to the pressure. Okay, what happens to the temperature of the vessel? So we can kind of keep pumping and saying, all right, we were negative 60 degrees Celsius. What's happening? Okay, are we increasing, decreasing, or staying the same? The more we pump in there. And you guys might want to reset too just to compare. Where were we at with our oxygen? Okay, as we heat things up. And then you guys kind of have a point of comparison where we just saw we were about negative 55. Okay, you guys can kind of see how your pressure keeps changing a little bit better. All right, so eventually if you pump enough oxygen into the vessel, the pressure increases and the lid will blow off. Now imagine if the lid was fixed and the container will not explode. What do you think will happen to the phase of matter if molecules keep getting pumped into it? So what's going to happen where you guys have some pressure built up in there and you guys have a lot of molecules? What are those molecules going to be forced to do? Okay, other part is you guys can reset your vessel, and the other way you guys can change it is by clicking and dragging the lid down. Okay, so reset your vessel, go back to oxygen and heat it till it becomes a gas. So again, we want oxygen, we want to heat it up until our oxygen is now a gas. Almost there. And change my degrees to Celsius if you haven't already. And then we're going to indirectly change the pressure by pressing down on the lid. So here we go. We can go about halfway. And then you guys can kind of move from there and see. Click and drag your finger down and push the lid down a little over half of the way. What did you directly change when you push down the lid? The answer is not pressure. So look at the other kind of pieces of data that you have to collect when you push down on the lid. Okay, so check some of those out. And moving on. Eventually you'll depress the lid enough, the pressure increases, and the lid will blow off. Now imagine if the lid was fixed and the container will not explode. What do you think will happen to the phase of matter? So this is the same question that we just asked looking at pumping air in. So what will happen? What will those molecules be forced to do? And from what you discovered in the interaction, what are 2 ways to turn a gas into a liquid or a solid? You guys already know one. Obviously, cooling it down, removing energy from it is one way. So what was the way you just examined that you guys can potentially turn a gas into a solid or a liquid? And this is again going to lead us into talking about dry ice and how we can make dry ice and why we see the phase change we do at dry ice at room temperature. All right, so you guys are all done with that. Go ahead and hand it in, and I hope you're having a great day. Bye.